Okay, so what we're going to do today is a paper vector lab, and not everybody has rulers with them. So I went ahead and made just a little measuring device on the corner of the paper, and you can either cut it out if you have scissors, or you can just tear it out neatly. And you're going to use that for this lab. And I start you off with two examples, one of the easier ones and then one of the more complicated ones, and I guide you through it, and I actually draw out the first two pictures here and the first two pictures here just as part of my explanation to try to help you understand what you have to do. For the second one, I fixed it since then. You probably have the old version if you're in class right now, where you might want to redraw it to scale. And you'll see what I'll give you an example. You'll see what I do in a second. Let's just go through some of the basics. So the first example says go 1.2 centimeters east, then 7 centimeters north. So what's done for you, once again, you're going to have to do this in the later examples, is draw the origin dot, and then follow it 1.2 centimeters east using the measuring tool to try to keep it as to scale as possible, and then that's 7 meters up, and label, you'd label the sides if you were doing the 3 on, they don't have the drawings for you. And then the second step that you're going to do here, this one only has two steps, only has a single x, only a single y. But if it had multiple x's and y's, which you'll see later on, you would have to put the x's together and the y's together, depending on how many there were, and then you would go ahead and then draw out an overall resulting x and overall resulting y. So you'll see that more in the next example. This one doesn't have it, so let's just follow along. So after you draw that out, then you want to draw the resultant line right here. So the resultant line and also the resultant angle. And so that's going to be what we're going to solve for here. We're going to go ahead and move on to step 3. And we're going to solve for the resultant angle, the resultant magnitude. So we're going to do the Pythagorean theorem to solve for this side right here, which is C, and we're going to do all the math, show all the work, and then we're going to put the final answer in that box. Next, when we're trying to find the angle right here, we need to know the opposite and we need to know the adjacent. And so here we have the adjacent, once again, to the side. Opposite is where it opens up. The adjacent's over here on the side. And then we're going to go to inverse tangent. And so we have 7 over 1.2, and we get 80.3. So all this work should be in this block right here. And then finally, just like before, we'll give a complete answer. So in this case, it's 7.10 centimeters, 80.3 degrees north of east. Once again, if you want to think about how that's done, the baseline is, in this case, east. It's coming out right there. There's your origin dot. Think of it backwards. It's not working. There it goes. So the origin dot has east coming out of it, and so east is the last of the description because we're going north from that east. So once again, we've had a couple of days of practice now. Hopefully we're getting better at this. I know not many people are great at the start, but this is why we have the practice. So, and that's why we're going to do more of this worksheet, just to get more practice to get it down. So you'll go through everything, and when you finally get the answer, you'll have, you'll do all this. And then lastly, you're just going to take your little mini ruler that you cut out, and you're going to measure it out. And I'm not going to take off if it's that far off. So just go ahead and measure it out and see. If these were drawn completely to scale and you measured everything out and you did everything you were supposed to do, this number would be exactly the same as the hypotenuse, that C that you solved for. So you measured this out right here, this side, and that should be the same as you calculated over here. So 3 and this number would be about the same. And that's what I expect for the most part, but I'm not going to take off if it's a little bit off, within 1 of my centimeters, which are not centimeters, but they're close to them. Okay, so on to the second example. On the second example, well, this now we have multiple vectors. We go 1.2 centimeters east, then 7 centimeters north, then 1.2 centimeters east. So this first block is showing you what actually happened. You started here, you went this way, you went up, you went to the right. Now for the second block, we now have to take this 1.2, because they're both x-axis components, and this 1.2, and put them together. And if we had 1.2 and 1.2, and that's what this is showing you right here, we can go ahead and do that, and we get an overall vector of 2.4 centimeters, and the arrow is drawn to the east. So that's all we do for these. If there was ever an up, two y's, we would put those together as well. I think some of the last problems I go through and I make you put together a bunch of vectors. So depending on what you're doing, if you, let's say this was what you were doing, if you had that and then this, well, you'd have to put these two together, figure out what, let's say that was 5 centimeters. So this is not this example, and that was 2 centimeters. Well, the overall would have been 5 minus 2, and so that would have been 3 centimeters up. It's not meters, centimeters up. And then you would have an overall, so this would be those two combined, and then the overall would look something like this. I'm telling you to do the x first. The overall would look something like this, and then that, where that was drawn right there, and then you draw the overall result, and you draw an angle. But if you've been paying attention to the lessons, you should have the just now of what to do here. So you're just going to go ahead and get the practice and maybe do a few extra steps by putting some of these 1D motion vectors together, so that you come up with an overall triangle. Notice how 1 plus 1.2, 1.2 equals 2.4, 7 is there. Really what I did was I moved this one over, and I moved that one down, and I turned it into a new triangle that ended up looking like that. And then there was your resultant. So that's all you have to do. Now, when you get to the last part, 3 through 6 you do like your last example, but when you get to the other page, I realized I had a couple errors because I just made this the other day. A lot of these blanks are not labeled. So if you have, like for example, you don't have these blanks labeled, just do the same thing. Do what you had to do before. And so just an example for this one right here. Here's my sample of what I had to do, and so we already did a couple close to being done together. You just have to finish off this worksheet for the day. But this is what the overall going 2 centimeters west, 5 centimeters north, 6 centimeters east, and then when you take the -2 plus 6, you end up getting 4 to the east instead. So these two right here ended up becoming the single axes, and we only had a 1y. So, and the way I told you, I gave you instructions: do the x-axis first and the y-axis, and so our vector triangles will look the same. Truly, it would be correct if you went north first and then east second, but just for the sake of things. And also make sure you have origin dots, make sure you have all the arrows included, and the hypotenuse and the second component should be button arrows against the same, well, not same exact direction, but it should be facing that way. And then just make sure you have all the math, and then make sure this one you just measured. So that one I would have just went ahead and I went to this side right here, and I would have measured whatever it was. This was my calculated value, whereas this was something I measured. So these might not be exactly on. See how mine wasn't 6.5 and 6.4. That's fine. Just go ahead and measure it. I want you to see that it's going to be pretty close. So that's what you have to do today. Go ahead and finish that off and have fun.